Okay, so how much is it from 8 to 20? 12. So D is 12. All right? And then to finish the function, I have to figure out how I either get from 12 to 8, or I go 12 in the other direction. Either way, I end up with negative 4. So a to the n is defined as 12n minus 4. Good? Okay, now, to find the sum, that's the formula we use. The first term plus the last term times n over 2. They're giving us n, which is 10. What's 10 divided by 2? 5. The first term is given as what? 8. We have to figure out what the last term is. Well, the last term is defined as the 10th term, so we're going to go back here and plug in what? 10. 12 times 10 is 120. 120 minus 4 is 116. You're then going to add 8 and 116, you get 124. And then multiply that by 5. And I believe we end up with 620. Seem good? All right, give the 2 underneath the whirl. Give the 2 underneath the whirl. I hate when I do that. The end is near, Tegan. The end is near. I need to figure out how I get money out of my life to pay you for that thing that these funds. I hope my wife doesn't watch the videos that I have on YouTube. Might be uncomfortable. How'd we do? Make sense? Where the numbers came from? Any part of that troubling you? The a to the 1 is 100? Okay, so I'm going back to this formula, which means I add a to the 1 and a to the n. Since there's 25 numbers, they're giving me the last number. Ah! I wrote the wrong number down. So that should be 320 instead of 350. I thought that number looked wrong. And then I'm going to do 320 times 12.5. And I believe I get an even 4,000. Better? Okay, sorry about that. Alright, so for that one, they gave me the values, so I just got to add them up and then take the total number of numbers and divide by it. Okay? Okay, now, buyer be warned. In the bottom, step 8, sigma notation. Find the partial sum of a sequence given sigma notation. So we can hit math and then 0, and it will give us sigma notation. And we can enter the data in. So if we look at the first one, it says n equals 1. I'm just going to replace the n with x. It's going up to 50, so I'm going to enter the 50 up there. And then it's simply x. And then I can hit enter, and it'll give me the value, which is 1,275. So I go here, I put 1,275, and I think everything's good in the world. You'll lose points because you will be required to show work. And what that work is, at the very minimum, is a to the 1 plus a to the n times n over 2. All right? The other steps that we're going to do here, I don't need to see, but I would need to see this with the values plugged in. So in other words, a to the 1 is the first value. So if it's just n, the first value would be 1. Everybody okay with that? A to the n is the last value. Well, the last value, when this is 1, is going to be up there. So I plug in 50, and I get 50. So to get this, I would do 1 plus 50, which is 51. Everybody good? Times the total number of numbers, which is 50, divided by 2. So I'd end up doing 51 times 25, which gives me 1275. This is what I would expect to see at the minimum. Alright, that is what I would expect to see at the minimum, going from there. Now, the second one has how many different summation notations? 2. So you're just going to do the same thing twice. If I do the first one, n is 11, alright, so a to the 1, if I plugged in 11, would be 11. A to the n would be the last one, so I'd plug in 30, and that would be 30. Alright, so to do that, I would do 30 plus 11, because that's the first and the last, times the total number of numbers divided by 2. Here's the trick. This one doesn't start at 1. This one starts at what? 11. So you have to figure out how many numbers there are. Now, an easy, straightforward way to do that is do the top number minus the bottom number and add 1. This is an additional one doing. So 30 minus 11 is 19. Plus 1 is what? 20. 30 plus 11 is 41. 20 divided by 2 is 10. 41 times 10 is 410. We would then do the second one. So the second one starts at 1. So a to the 1 is 1. And ends at 10, because that one starts at that. So it's 10 and 1. For that one, I would again add the first and the last. So that's 1 plus 10. Times the total number of numbers. Now, since this starts at 1, 10 is the total number of numbers, whatever that is. So 10 divided by 2. 10 divided by 2 is, of course, 5. All right? 1 plus 10 is 11. 11 times 5 gives me 55. And then what operation in the instructions does it tell me to do to those two values? Subtract. Or just subtract my values, and I'd end up with 355. All right? So if you would, keep that in mind. Work on those three, the next three. All right? Realizing this one starts at 0, not 1. So you got to make a small little adjustment with that. The next class notes of the year, geometric sequences. Geometric sequences. 1, 2, 1, 1, 2, 1, 2, and 3. 1, 2, 1, 2, 1, 2, 3. 1 and 2. Over here. How are we looking thus far, okay? You alright? What's the matter? You want me to walk through the last one? That's fine. 41? Yeah. I plug in whatever this value is to the formula. Sorry. That's alright. So I just plugged in 20, so 2 times 20 is 40, 40 plus 41. So basically, Grace, what you're going to do is you're going to plug in the bottom number and the top number. Make sense? Yeah. All right, you ready, Emily? Okay, so to get a to the 1, I plug in whatever this value is, which is 1. So I plug in 1 to this, so I'm going to do 250 minus 2/5 times 1. and it's going to give me 249.6. You okay with that part? So that gives me 249.6. Then to get the last value, you plug in the top number, which is 60. So I'm going to plug in 60 to this and do 250 minus that value. That comes out to 226, I believe. Oh, 250 minus 24. 226. So you okay with that part? You're just plugging in. Okay. So now you're using this formula, which is S of n equals the first number plus the last number times n over 2, where n is the total number of numbers. Okay? So I'm going to take the first number, which is 249.6. I'm going to add to that 226. Now, when this number is 1, whatever this number is up top is your total number of numbers. So for this one, I can just multiply that times 60 over 2. Good? So now I'm just going to add 226 to 249.6 and multiply that times 30, and I get 14,268. Now, the only time you got to be careful is when this isn't 1. So that's why, since this starts at 0, there's not 100 numbers. You got to include 0, so there's actually 101. So that's why that one is 101 over 2. But if I plug in 0 to this, 0 plus 5 is 5. 5 over 2 gives me 5 over 2. If I plug in 100, 100 plus 5 is 105. That's 105 over 2. So I'm just going to add those together, and when I do 5 over 2 plus 105, since they have the same denominator, that becomes 110 over 2, which is 55. So I would do 55 times that fraction and give me the answer. You're going to practice it, like I said, next week, and then we'll go through the solutions before you have an assessment. Better? Okay. Everybody else good? Okay.